my name is Melanie Looper. Again, I'm a student in Professor Fox's CHEM1405-64400 Maymester class, and this is me doing lab number 2, the online electron configuration simulation lab. I have my laptop set up here with everything on it, have my worksheets here, so I will get started, and that's what I'll be working on for the next 6 to 9 minutes. So I have the website open. Click on the box for element 12, magnesium. Okay, my screen looks like that. Click on the periodic table button to return to the periodic table window and press next. The diagram represents the energy levels of atoms from the lowest energies to higher energies. Sketch the diagram below. So this is what I'm seeing, and I'm going to draw that now. One, two, three. 1, 2, 3, 4, 5. 3D. One, two, three, four. 1, 2, 3, 4, 5, 6, 7. One, two, three, four, 5, 6, 7 for 4F, and then the same thing for 5F. Okay, so I just drew what I'm seeing on my screen. Each box in the diagram is called an orbital and represents the region in space that the electrons in an atom can occupy. Okay, the numbers in the diagram label the energy level of the orbital from lowest to higher, and the letters identify the type of orbital at each level. So there's S, P, D, and F. Orbital types are grouped together in the diagram and have specified letters. How many S orbitals are there at each level? How many P orbitals are at each energy level? How many D orbitals are at each energy level? And how many F orbitals are there at each energy level? Fill in the following table with your results. So it looks like at 1, there's 1 S orbital and no P, D, or F ones. At 2, it looks like there are 4 P orbitals and none of the rest. At 3, it looks like there are 1, 2, 3, 4, 5, 6, 7, 8, 9 D orbitals and none of the rest. At 4, oh, there's a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 F orbitals and none of the rest. And then at 5, it's the same as 4. So 16 F orbitals and none of the rest. Okay, so sorry, I got cut off. So I put that down in the table. Next question. Speculate on why there are more orbitals at higher energy levels. Consider what happens to the geometry of an atom in three-dimensional space as one gets further from the nucleus. So I would assume that there would be more orbitals because there would be more electrons, because as you're building, there's going to be more and more, would be my assumption. So I'm going to write that down. Okay. As the electrons get further from the nucleus, the geometry grows, and there would need to be more orbitals to house more electrons, is my answer. Speculate why some orbital types have more orbitals at each energy level. How might S and P orbitals be different so as to account for different numbers? Speculate why some orbital types have more orbitals at each energy level. Well, I would assume that, similar to the last question, you need more orbitals as you're going farther away from the nucleus because you need more orbitals to house those electrons. So S and P orbitals would hold less electrons because those are closer to the nucleus, and that's why they would account for different numbers, I believe. So I'm going to write that down as well. Okay. Click on the next button to display the hydrogen atom. Sketch what you see in the diagram. Okay, so I'm seeing an arrow on the first energy level, a down arrow. So I'm going to sketch that. Click on the next button to display the helium atom. Sketch what you see in the diagram. Okay, so we added an up arrow in the same orbital on the same energy level. Oops. Okay, so just drew here the down arrow in the first one that I saw, and then the two arrows in the next one that I saw. What do the arrows and the orbitals represent? I'm pretty sure this represents like the electron spins or like the electron movement. Why are the arrows pointed in opposite directions? What does the direction of the arrows represent? Electrons can be thought of as particles that rotate on an axis. So it represents where the electrons are spinning, if they're spinning down, or if they're spinning this way, or if they're spinning this way. And I would assume that you couldn't have them both turning the same way at the same time. Electrons have common negative charges and consequently repel each other. Why would the second electron in helium go into the same orbital as the first electron instead of a different orbital? I guess it means that it would be okay if they're going in opposite directions, even though they're both negatively charged. wrote that down. Next element is lithium. Where would the next arrow go and why? The next arrow I feel like would go in this orbital, and it would be a downward pointing arrow because it doesn't look like there's any more room for another arrow in that orbital. Okay, that was correct. I just pressed next and saw where the arrow went. Okay, so I'm going to write that down. I'll end the video here because I'm approaching a long video. So yeah, I'll finish up this lab and get it turned in.